Name each of the following compounds. We have CuI, CuI2, CuI2, and Na2CO3. First things first, we have to figure out what is our compound made from. So here we have copper and iodine. Copper is a metal. How do we know that something is a metal? These are elements to the left of the staircase. So all of these are metals. This is our staircase. And all of these are non-metals. Non-metals and metals. So we have copper, which is a metal, and we have iodine, which is here, and this is a non-metal. If we have a metal and a non-metal, this is an ionic compound. So if we see that our compound consists of a metal plus a non-metal, it is ionic. How do we name ionic compounds that consist of metal and non-metal? We write the name of the metal, Cu is copper, and then we write the name of the non-metal ending in "ide." Now here our name is iodine, but we have to end in "ide," so this is copper iodide. Another thing that we have to keep in mind when we're naming ionic compounds is to keep in mind transition metals. Transition metals are located here, and these are the metals that have multiple oxidation numbers, or multiple charges. If we have a transition metal, we have to write its oxidation number as the Roman numeral in parentheses. So here I have CuI, and I have to figure out the oxidation number of my copper because I noticed that copper is a transition metal. What I'm going to do is I'm going to figure out the oxidation number of iodine, and then using the formula go through to the copper. Now we have to remember that group 1 has a +1 charge, group 2 +2, group 17 -1, this is -2. Notice that iodine is -1, so iodine has a -1 charge. Let's go ahead and bring it here. Iodine has a -1 charge. What charge does copper have to make CuI? When the a cation and anion come together, the molecule overall, our compound overall has to be neutral. So if this was -1 and this is CuI, Cu has to be +1 because +1 and -1 give me 0. Another thing that we can look at is we can look at the subscripts, because generally speaking, the trick is to cross multiply to give these oxidation numbers as the subscripts to each element. So we get CuI like that. I know now that my copper has to be 1, so I put Roman numeral 1 here, and I get copper 1 iodide. Now let's go to the second example. I have exactly the same molecule, so I'm still going to have copper and I have iodide, but now my formula looks different. There is a 2 here. So how do I figure out the oxidation number, the Roman numeral for my copper? If I have CuI2, I see that there's a subscript 2 next to iodine. How did it come about? Well, iodine was -1, so that one here, that's why. And by the way, if you don't see any numbers, that represents 1. That's why we see Cu. And what charge did Cu had to be for the iodine to have 2 next to it? It had to be +2, because if we cross multiply, we go here. Another reason we can explain this is if iodine has a -1 charge and Cu has a +2 charge, I need 2 iodines to make this molecule neutral. So I am going to put 2 here, and I will move on to my next compound, COI2. Where is CO? We can look for it. It's a metal, and it's a transition metal again, which means we will need to use the Roman numeral. I, again, we said it's non-metal. Again, metal, non-metal is ionic compound. How do we name it? The name of the metal, which in this case is cobalt. The name of the non-metal ending in "ide", iodide. And we said that cobalt was a transition metal, so we had to put Roman numeral here. What Roman numeral should we put? We should put the Roman numeral that's next to iodine. So it's 2. We have 2 here. Cobalt 2, iodine, just like copper, because we see 2 next to iodine, and we know iodine is -1. Copper had 2, cobalt has 2. So this is cobalt 2 iodide. And let's go to the next one. What is this? Na is a metal. This is a metal called sodium. Next to it, we see multiple elements. This is what we call a polyatomic ion. You will have to memorize a lot of polyatomic ions, or your teacher or professor will give you the polyatomic ion chart, but we have to know their names, the charges, and the formulas. If we have a metal and a polyatomic ion, it is also an ionic compound. How do we name it? We name the name of the metal, which in this case is sodium, and the name of the polyatomic ion. CO3 is carbonate. So this is sodium carbonate. Now, do I need the Roman numeral? Well, sodium is not a transition metal, so no Roman numeral is needed. This is sodium carbonate. This is Maya Lochi, and I really hope that you found this video helpful.